In this video, I'm going to show you just how easy it is to build your own MCP tools and run them right inside VS Code. It's fast, powerful, and lets you connect your AI assistants directly to external tools. So, what exactly is MCP? MCP stands for Model Context Protocol, the new standard that allows AI assistants to securely use external tools and data sources in a way that's consistent and safe. Let's build a quick weather tool using TypeScript, one that an AI can call to get real-time weather information. Here, we've got a fresh Node.js project with a Model Context Protocol package already installed. First up, we install the create MCP server function and spin up a new server with a name and version. Then we pull in the create standard IO transport, which lets the server talk over standard input or output. This is perfect for local development in VS Code. You could also use the HTTP transport, but that's better for client-server setups. For the weather data, we will use the public API at api.weather.gov. Let's set up a base URL and a user agent. This is required for accessing the API. Now, let's write a little helper function to fetch the weather data. It's a generic function that takes in a type of T and returns the same type T. If you're not familiar with generic functions, they're just like normal functions. The only difference is they can handle multiple types. We send the request, include the headers. This contains the user agent that we defined above, and then we get back a properly typed data. Now, let's define types. First up, weather alerts interface. This interface includes the alert event, the area, the severity, and more. Typing your tools is super important. If you don't type tools, the LLM might not know how to use them. We'll also stringify the alert response, so it's clean and easy for the LLM to consume. Next, we define types for the forecast periods and the forecast response. Now, let's build our first MCP tool, getAlert. We import Zod for input validation and define the tool name, a description, expected inputs. This is validated by Zod, and then we define the function itself. We pass the right parameters to our helper, check for valid data, and format the response. If there's no data, we want to return a helpful error message instead. Time for the second tool, getForecast. It follows exactly the same pattern: a name, a description, an input schema, the API call, and the formatted output. This keeps the structure consistent and the tool predictable for AI use, which is very important. Now, let's hook this up in VS Code. You can either create an MCP server config file manually, or preferably, use the built-in command by pressing Command-Shift-P, selecting Add MCP Server, and following the prompts. You pick the standard IO transport, enter the start command, in this case npx tsx index.tx, give it a unique server ID, in our case getWeather2, and choose where to install it. We'll use the workspace for now. VS Code sets up everything and starts the server automatically. We have the ability to stop, restart, or see more details about our server. Now, let's test it out with the GitHub Copilot in agent mode. We'll type, "What's the weather in Chicago?" As we can see, Copilot instantly detects our getForecast tool, fills in the correct inputs, and calls the tool. Clicking continue, we see that the weather data is returned live from our API. Let's try the alerts too. Give me weather alerts for Texas. Same flow. The tool gets picked up, the values are passed in, the results are returned. Here are the active alerts as of July 17 in Texas. There you have it. You've just built a simple MCP server in TypeScript. The same concept works in Next.js, NestJS, or even other frameworks. If you want to see how to implement this in Next or Nest, drop a comment and let me know. Thanks for watching. See you in the next one.